you for joining this walkthrough of the University Dropout Risk Analytics platform. This robust application uses Streamlit, MongoDB, and Python scikit-learn to predict students' dropout risk. The system is designed to provide role-based intelligence, ensuring every member of the academic team, from the admin to the individual mentor, gets the data they needed precisely when they need it. Let's start logging in by the system admin. The admin's core task is to upload weekly student data. We need three files: attendance file, assessments, and fees. When I click on the process and save, the backend does four things for us. One is it runs the data through the machine learning model to generate a dropout probability, analyze the risk level like high, moderate, as well as low, and saves all the predicted results to the MongoDB database. And here we have the risk distribution. The pie chart shows the percentage breakdown of the entire student body by risk level. This guides high level resource planning. Next, we have performance analysis. These two scatter plots are critical for understanding the model's behavior. We see the clear correlation. As marks or attendance fall, the dropout probability increases. These red dots, representing high risk students, cluster dangerously close to zero attendance as well as low marks. Next, we have the department overview. These box plots compare the central tendency and spread of metrics like attendance or marks across all the departments. This allows the admin to spot which departments are struggling or excelling dividing policy decisions. The main table here, every student showing their computed risk as a progress bar. Student marks as green for low risk, yellow for moderate risk, and red for high risk. The high risk students are for our immediate intervention. The admins can use this send high risk alert button. When clicked, it triggers an email notification to the mentor of these students, automating the intervention handoff. Now let us log in into any one of the mentor ID to check if they have received the email. Here we can see that the corresponding mentor had received an email telling his mentee has been flagged as a high risk and they need intervention. To demonstrate how platform tracks progress, the admin can quickly add files of corresponding weeks like week 2, 3, 4. Now let us continue the same process for week 3 and 4 simultaneously. Here I have updated the files till week 4 and all the corresponding visualizations and the main table has been updated till the week 4. The process continues as the semester goes on. Now let us log out as the system admin and start logging in as the principal of the institution. Now we have logged in as the principal. We have exact same university-wide view as admin, but without any permissions to upload files or process new data. The principal role is to oversight. They use charts, especially the department overview box plot, to compare the department's performance and identify the systematic issues across the campus. Now let us log out as the principal and start logging in as any of the HOD, for example HOD of CSC. Switching to the HOD of computer science, the data scope now narrows instantly. The dashboard title is specific. The main table shows only students belonging to the CSC department. The risk distribution is now as follows. The pie chart now only reflects the risk profile of CSC students. The department overview. The HOD can still access this tab, but since their data is already filtered, the box plot now acts as a deep dive summary of their own department's internal performance and score spread. Now let us log out as a HOD and start logging in as the mentor. The final most critical role is the mentor. After logging in, the dashboard is filtered. It only shows their assigned mentees. The mentor receives the high email alert and immediately looks for their list of high-risk students. Now by clicking any of the students, we will have the student metric page. The performance trend analytics. This line chart shows the students' attendance and marks trend all over the 4 weeks, from week 1 to week 4. You can clearly see if the risk is due to a sudden recent decline or gradual sustained poor performance. Next, we have the comparison bar charts between students' attendance with the department average attendance and the students' marks with the department average marks. Next, we have the dropout probability GOG, which provides the immediate risk value showing how close they are to the 1.0 threshold. The next important part is we have a mentor note. This is the action area. Since the student is high risk, the mentor can use this text box to create the reason for high risk and intervention plan. This note is saved to the database. Let us suppose add any of the note like financial problem. And when we hit on the save note, and when we go back to the dashboard and look into the student of 159th roll number, we will have the financial problem noting here. So this is overall mentor overview. In conclusion, the University Dropout Risk Analytics platform successfully centralizes ML predictions and student data into secure role-based application by providing targeted time-sensitive intelligence to admins, principals, HODs, and mentors. It directly contributes to improving student retention and academic success. Thank you for viewing the demonstration.